Hello world, Nick here with part 3 of my Java programming tutorial videos. So today what we're going to do is we are going to talk a little bit about what is actually going on here, all this voodoo that I wrote here which magically made words show up down here. And we are going to also talk about numbers, because numbers are pretty important when it comes to programming. Don't worry, you don't need to know any math. The computer does that for us. So let's talk about a little bit about what happens here. So when we click on run, what actually happens is there are a few steps that are kind of hidden here. First, what happens is that our program is compiled. So there are a few steps to that, but basically what it comes down to is that we give our program this text right here. We give this program something called a compiler. You don't have to worry about how that is or why those work. But you give it this text right here. You give it a Java file, a .java file. And it goes through that and it turns these words right here, all these things which we just wrote, and it converts them into binary code which the computer can read. So again, there are a few steps in between that. There's also an assembler which turns it into assembly code which your processor understands, but those are just details which don't really matter too much. So, so after it turns into code which our computers understand, it runs not on not on the computer itself, not like straight onto the hardware, like some languages, like if you wrote in code in C, it would run basically straight onto your hardware. But with Java, the way it works is it runs on something called the Java Virtual Machine. So the Java Virtual Machine is basically something that makes it so that all Java code, no matter what software it's written on or how it was written or anything like that, it'll all run in the same exact way. So sometimes like with software there's problems because it works correctly on a Mac but not on a Windows, or like a video game has a glitch on the PS4 but that it doesn't have on the Xbox, or whatever the case is. But with the Java Virtual Machine, that's sort of all taken care of because all the code runs as if it's on the same exact system, which kind of makes it slower than a lot of languages, which is why in general Java isn't too common to make video games in, or any sort of really CPU intensive software. But it it ends up having a lot of benefits as well. So then the code runs in the Java virtual machine and it sends us this output at the end, hello world. So that's basically what's happening within the machine. If you'd like, you can just erase the last 3 or 4 minutes of memory out of your head, pretend we never had this conversation. That's fine. You don't actually have to know how this works right now, but if you're curious, that's basically what's going on. So we want to make a program that does something more than just say hello world. How about if we made a program that adds 2 numbers? So we want to save our great hello world program. So what we're going to do is create a new project for our number adder. So we do that same way. We go to File, New, Java Project, and then for project name, we are going to put in adder. And again, you can leave this all the same. No need to worry about any of that. So you'll see now that project showed up right up here, right above our hello world. So these are all the projects that are in our workspace in Eclipse. So we're going to do the same thing. We're going to go to source, new, we're going to create another class. So let's call this one adder, and we want that public static void main string args there again. So everything here looks good. Let's click on finish. And we have the same thing we had before, except this time instead of saying hello, it says adder, because that is what we named our class. We want to make a program that can add two numbers. So we want to have a program that can store two numbers in it. So the way we do that is we create something called a variable. So variables are sort of like what they are in math, what you like to think of them as in math. It's the name we give to something, to some piece of data. So that can either be, it can store, a variable can store a number, it can store a list of numbers, it can store a string of letters, it can store a picture, it can store a file, it can store pretty much anything. So when we create a file, or not a file, when we create a variable, the first thing we want to do is tell Java what kind of variable we're making. What are we going to put inside of it? Because this affects the way that Java sets aside like memory in the computer for us to use for it. So it has to know what we actually want to put in there. So we're going to be adding numbers. Particularly, we're going to be adding integers. We're going to be adding whole numbers. So what we're going to do is to tell Java what we're going to store as an integer. We're going to write int. So what we're doing now is we're saying whatever variable we're going to make up after this, it's going to be of type int. It is going to be an integer. So let's call our first variable x. That's a good name for a variable. Probably seen that before way too many times. And now we're going to put a semicolon at the end of that to say we're done. We made our variable called x, and that's what we're doing on that line. So now we're going to come down here, right under it, and we also want a variable called int y, because remember we need two numbers. So variable names don't have to be one letter, they rarely are. A variable name can be anything. The one rule for a variable name is that you can't have spaces in it. It needs to be all one word. So let's say that we wanted to name our variable something like first number and then second number instead. We can't do that. See, Eclipse is going crazy here. So what you normally do, different programming languages have different styles where you do different things. But in Java, the standard thing to do is if we want to have a variable that has a name longer than one word, is we use something called camel case, which is you leave the first letter lowercase, but then instead of putting a space to denote a new word, you make the first letter of that new word capitalized. So that first space number becomes first number with no space and a capital N, and second space number becomes second number with no space and a capital N. So what we want to do is we want to print out, the same way we printed out hello world, the sum of these two numbers. So if I ask you to guess how to do that, you'd probably be pretty close to right. What we do is in here we just put in first number plus second number. We put the semicolon at the end. So the reason that we don't need the quotation marks here while we did in hello world is because hello world is a string of characters. So whenever we write a string of characters, just a literal string, and that's what we want to give it, then we would put quotes around it. So let's just look at what would happen if we put quotes around here, the same way we did for hello world, and then we ran it. You see, it just prints out down here first number plus second number. That's not what we want. We want to actually add the two numbers. So whenever you have anything within quotes in Java, it doesn't actually do anything programming wise with it. It just takes that for what it is. So in this case, we print out just exactly first number plus second number, but we don't want that. So let's get rid of those quotes. So now Java doesn't like this because it says local variable first number and second number have not been initialized. So what that means is that it can't add these two numbers because these two numbers don't actually have numbers assigned to them yet. What we did up here was we basically told Java we were going to have a variable called first number, we were going to have a variable called second number, but it didn't give them an actual number. So to do that, down here, we can just say first number, and we say equals 8. So what this does is it takes the variable on the left and it sets it equal to whatever's on the right. So in this case, first number becomes equal to the number 8. So now let's do second number and set that equal to 10. These are just two integers. You can put anything you want there. You can put negatives if you want, it's fine. So now let's see what happens, because the x there ran away, which means that now we can run our program. Now hopefully this should print 8 plus 10, so it should print 18 if we're lucky. Are we lucky? Yes, we are. It printed out 18 right there, so it printed out 8 plus 10. So what do you think would happen if we change this 10 over here to first number? It looks really weird because first number isn't, like, we don't actually see that as a number, but Java knows that first number up here we're making it hold the number 8. So right here when we say second number equals first number, is we're saying second number equals whatever first number equals, and first number equals 8. So now when we run this, what do you think it should print? It printed out 16, which is what we get when first number is 8 and second number is 8, because 8 plus 8 equals 16. So one last note here is this was only one of the two ways we could have created these numbers. Another way we could have done it is in this line up here, you can also put int first number equals 8 and put that up there, and int second number equals first number. So when we set it up like this, what we're doing is we're telling Java that we're doing two things up here. First, we're telling Java, get ready to hold this variable, which is an int, and it's called first number. And we're also telling it that we want it to hold the value of 8 inside of it. So we're kind of doing two lines at once up here. And Java lets us do this, which is pretty cool. And then we're doing the same thing here with second number. We're telling Java we're going to have an int called second number, and in it we are going to store the value of first number. So in Java, if you just have one equal sign, that doesn't mean equals the same way that it does in math, really. What it means more directly is assignment. We're taking whatever the value of the thing on the right is, and we're assigning it to whatever the value of the thing on the left is. So that's why first number, as far as the computer is concerned, holds 8. That's whenever we write out first number, the way that the computer is going to read it is it's going to read it just as if that number were 8. So if we did switch this to 8 plus 8, we should get the same thing. And we do 8 plus 8, because Java treats wherever we use the phrase first number as if you had just typed the number 8 instead. So now we made a program that can add two numbers. So that's cooler than a program that just prints out a few words, I guess. Anyway, that's it for now. If you have any problems with any of this, leave them in the comments. Try to get back to them. See you all later.